Hello everyone, welcome back to day 3 of Unit 1. Today we're going to talk about combining like terms. So I know this was already in your summer packet. You got a little intro into like what terms are and everything like that. So a lot of it's going to look very familiar. There are a couple problems that we added onto it. So make sure you complete everything. But yeah, this is basically how we're going to simplify algebraic expressions. When we are asked to simplify, there's one or two things that could happen. We're either given the value and we can evaluate it like we did the other day, or we're not given the value of the variables, so we just have to simplify with what we got, which isn't a whole lot. So to simplify algebraic expressions, what we can do, we can distribute anything that we need to, and then we can combine like terms. Today we're going to focus on the second step. Next class we'll focus on, or next video we'll focus on the distributing part, but we're going to talk more about combining like terms today. So when you are combining like terms, it's really important that you understand what a term is. So that's what we're going to focus on first. Terms are parts of an expression that are separated by an addition sign. We're only looking for separation by an addition sign. Now this can be a little tricky because sometimes the addition sign is in the problem. Sometimes it's not. Sometimes it's masked by a subtraction sign. So we'll talk about what to do when that happens. Okay? So here are some examples. So we have negative 4xy. That whole thing is one term. Even though it's got three separate parts, it's got the negative 4, the x, and the y, they're all being multiplied together. So they are all considered one term. Okay? So that is one term. Here we have x squared minus 16, so a minus sign. Okay? This is actually two terms. So I'm going to show you why. Because if I replace that minus sign, in class we talked about like double signs and stuff like that and how we can simplify them. Now we're kind of undoing that. Instead of saying minus, we could write it as x squared plus negative 16. It means the exact same thing. So what that means when you see a minus sign, that minus sign is just being tacked on with a number right behind it. So our two terms are x squared and, let's see, negative 16. Okay, so just lump it with the one that's right behind it. So there are two terms there. Here we have negative 4y plus 6x minus minus xy. Again, we have that minus sign. So I could rewrite it with a plus sign and it would look like this. Negative 4y plus 6x plus negative xy. I just take that minus sign and I apply it to the term right behind. So I make it negative. Okay? Knowing that now, I can see all three terms. So here, these two are separated by a plus sign. So those are two separate terms. And now, with this plus sign down here, it also separates the negative xy. So that creates 1, 2, 3 terms. Okay? You guys are going to try these on your own. Just tell me how many terms are in each expression. Okay? So it would be very helpful for you if you tried to box the terms. Okay? Like I did in the example. Alright, so you can pause the video now and do these three, or you can come back to it later. Next, we need to know what like terms are, because step 2 is combining like terms. So just knowing what a term is isn't enough. Like terms have the same variable with the same exponent. So just because this one has an x and this one has an x doesn't mean they're like terms. They have to have the same variable and the whole variable part. So some of them have multiple variables in it. They have to have all the same kind of variables with all the same exponents on those variables. Okay, so some examples of like terms. 4 and negative 7 are like terms. And the reason they are is because they don't have any variables or any exponents. So that's okay. You combine 4 and negative 7 all the time. You can add 4 and negative 7. Those are like terms. Another one would be 6x and 92x. They have the same variable of x and they have the same exponent, which is really 1. You can't see it, but there's really a 1 there. But they're still the same because you don't see an exponent. So those are combinable. Y squared and 8y squared. They both have the y squared part, which is what's important. And then 5abc and negative abc. they both have the ABC portion. Okay, so even though they have 3 different variables, they both have the exact same 3 different variables. So those are like terms. Some examples of non-like terms. 3y and x and 3x. Just because they have the same number in front does not make them like terms. They have to have the same variable. Z and z squared. Yes, they have the same variable, but they need to have the same exponent. This guy's got a square, this guy doesn't have one. So they are not like terms. 4ab and 4ab and abc. Yes, they both have the AB part, but this guy's got the extra variable of C, so that makes them not like terms. Okay? You guys are going to try this on your own. You have a whole table. Yes, it's from your summer packet. And you're going to find the circle that it belongs to. And the circle it belongs to are the ones that have the same like terms. So you need to find the like terms and then put them in the circle. Okay? So try that on your own. You can either do it now or you can come back to it later. And lastly, we're going to talk about how to combine like terms. So we know what a term is. We identify which ones are alike. Now we need to combine them. So to combine them, you're going to add the coefficients of the term. So the coefficient is a number being multiplied with the variable. It's a number in front of the term. Okay? Those get added together. We do not touch the variable or the exponent at all. Those stay the same. Okay? So here's a couple of examples. We need to simplify the expression. We're just going to combine like terms. So this is what I do first. I go through all my terms. Nope, don't do that first. Ignore it. I have a 2a, I have a 3a, and I have the negative 8b. Okay? My like terms are the ones that have the same variable. So the a's can be put together. I like to color code or use different shapes to figure out which ones are alike. That way I can keep a track. The negative 8b doesn't have any like terms. So my like terms, I will take the numbers in front, 2 and 3, and add them together. That's going to create my new coefficient. Okay? So it's going to be 2 plus 3, whatever that is, for the A, on the A, and then the negative 8b, because it didn't have any like terms, I just bring it back down. Okay, so now I can go ahead and simplify this. 2 plus 3 gives me 5, so it's 5a. There are 5 a's total. If you have 2 a's here and 3 a's here, you have 5 a's total, minus the 8b. Okay, b, I'm going to do the same thing. So I have a 5n, an n, and a negative 3n cubed. So 5n and n and n are the same because they both have just n's. Negative 3n cubed is different because it's got that different exponent. So I did that in a different color. So now I'm going to go ahead and combine these guys. So here I have a coefficient of 5, but wait, I don't have a number here. Anytime you see a variable without a number in front, it really does have a coefficient. It just has a coefficient of 1. Okay? So I'm going to add the 5 and the 1. And then I put the n on the end of that. Minus the 3n cubed because I didn't have anything to combine with it, so I just bring it down. So now I can simplify. 5 plus 1 really gives me 6 n's. So I had 5 n's here, 1 n here, minus the 3n cubed. Alright, C looks a little lengthy. I'm going to go through. I got a 6x squared, a 9x, a y squared, a negative 9x, and a negative 4y squared. Okay? So now I'm going to go through. So I have an x squared. I think I did this wrong. I totally did this wrong. So my notes are going to be a little off. I've got a 6x squared, which actually should not be that color at all. It should be something else because it doesn't match with anything. Let's make it yellow. Okay, there's no other x squareds. None. Okay, I've got a 9x and a negative 9x that go together. And then I've got a y squared and a negative 4y squared. So here's where it's going to be funky. Okay, don't copy this because it's wrong. Edit. I just want to edit. Oh, how about I just delete it? So, a 6x squared that has nothing else to match with, I'm just going to write down. Okay? then I can look at, let's look at the y-squareds. This guy has a coefficient of, show. There it goes. Has a coefficient of 1. This guy has a coefficient of -4. So, I'm going to go ahead and do that. Sorry, things are funky. So now I have 1 minus 4 for the y-squareds. Okay? And then, for the x's, I've got the 9 minus 9 x's. Okay? So now that I've combined my like terms, I can actually do the math for it. Oop, things are stretching. What's happening? Stop. Goodness. Okay? So, what I'm going to have, I'm just going to copy it. Sorry, I know it's kind of getting weird. That's okay. We're going to focus on it. Come on, just paste. Oh, goodness, guys. Technology is not my friend today. It really did not like my class. Alright, so now I'm going to change the 1 minus 4 to be a -3. And I'm going to change the 9 minus 9 to a 0. So here's the thing. I've got some things I can change. I've got 2 signs, so I can adjust that. And I've got a 0x, which just means 0. So I really don't need it. So I'm going to copy it again, because I don't have time to write it. I'm trying to make a fast video for you, and it's not going too hot. And I'm going to get rid of the 0x because I don't need it. And then this plus -3 really means I can just put a minus sign in there if I can get the thing to work. -3. So this guy would be my answer. Okay? You guys are going to try these 2 on your own. I highly recommend using boxes or different colors or different shapes to figure out which ones are your like terms so you don't forget any. Okay? We will go over the try on your own's next class. Other than that, if you have any questions, go ahead and write them down, and I will see you then. Bye!